So first of all, I'm just going to give you like an overview of what we do at the division so you can sort of understand where your classes are fitting into what's happening at UC Berkeley. So who is the Division of Data Sciences? Well, one way to think about it is we have two huge classes on campus. One is this big class, Data 8, one of the most popular classes at UC Berkeley right now. So we have 1,500 students each semester and something like 700 over the summer. We're getting to like 1/3 of the students right now. So 1 in every 3 students is taking this class. So one of our hopes is like, if 1 of every 3 students or one out of every 2 students starts taking this class, more and more we can transform how classes are taught. More and more students, as they get to upper division classes, if they have this familiarity, they'll be able to do more interesting things later on. The other huge class, 850 students each semester, Data 100. So this is for people who want to go into data science as something they're majoring or to add it on to computer science. Like 200 people on the waiting list. So really big class of people. There's also graduate students taking this class who want to level up on their data science. They've just started a data science major. It just went through in September. And the first 10 people graduated in December, but the first graduating class will be in May. 1,000 people signed up for it. There's probably going to be, we don't know, like several hundred, a few hundred. So a major that didn't exist last year is going to have like 300 graduates this year. So it's a sort of a big thing that's happening, and the students are excited about it. This is a little map of the major on the bottom. Here's like these big classes, Data 8 and Data 100, and then there's some classes out in other majors. This is what I want to say, like a domain emphasis class. So you can take classes in geophysics and have them apply to your domain emphasis in data science, or you could take an applied upper division class in some methods, some sociology methods, or something that's like an applied upper division thing that might have some quantitative thing, and that would be something from outside of data science that would apply for the major. So it's kind of crazy to teach a 1,500 person class. They teach the first few of them in Zellerbach so that everyone can have a seat. After that, they move them to Wheeler, the biggest room that they can, and only 2/3 of the people actually can have seats in the class. What's really important is that baked in throughout this class is a lot of computing. You can, and I encourage you to go sometime and sit in if you ever see it. It's really cool to watch when the professor's sort of teaching some concepts of computing, and then using this method, all of the students are simultaneously can be on their laptop and doing the same thing that the teacher's doing. They'll have like a local copy that they can follow along with, and he'll be giving some example. And it's a really powerful sort of pedagogical tool. But it takes a lot to enable 1,000 people to be simultaneously computing the same thing at the same time. So a lot of this is like this infrastructure has been built for this class. And so we'll talk about that. First of all, there's a few different places doing data science, and so a little bit of nomenclature because it's confusing. The D-Lab. Does everybody know what the D-Lab is? D-Lab? D-Lab is for training graduate students to be awesome and have the tools that they need. You can go for a 2-hour class. You can go for a week-long class. If you want to learn Python, you want to get better at R, you want to do machine learning, there's something for everybody there. So go to D-Lab, learn more. BIDS is the Berkeley Institute for Data Science. It's in Doe. It has a whole bunch of postdocs working there, and people doing really interesting things from all different fields. I think 2 of the people here sit at BIDS. Is that right? So sometimes. Stop by BIDS and see what's going on and check their calendar. There'll be somebody from something in your field that will be presenting at some time during the semester. And then we are the data science education program. We work with undergrads. We're interested in sort of like outreach to undergrads and what we do. We help support these big courses, and we help work with you guys to get into more and more courses over time. You may have heard there was a big announcement in November. So they're forming a new division within the university called the Division of Data Sciences that's going to collect people that are interested in this into like sort of research focuses where they could like get grants and people could share their appointment and continue the work that we're doing with teaching. Here's a really weird infographic that says what's going on with the division. I'm just putting this up because I think it's funny. There's these polymorphic shapes in there, that application, implication, foundation, and where do you stand, and how many sides do you have, and I don't know who was making that infographic. But anyways, we're down here. Importantly, we're going to join the iSchool and BIDS and the Data Science Education Program within the coming year. So over next summer, there'll be like some consolidation. Right now, the iSchool's over here, BIDS is over here, Data Science Education is over here, so there's like, bring it together and rationalize it is like the important part of the story. And we pull largely professors from engineering and statistics, and they're in completely different colleges, so it's like facilitate a way for them to work together. So data science bridges many fields, puts it in a weird place, but like make a facility for them to be connected. What about you guys? We are super interested in working with graduate students. We work largely with undergrads, but if you guys are interested, there's a lot of cool projects to work on and cool stuff to do. We are interested in getting away from statistics and computer science and working with people in all fields. We're interested in working with econ, humanities, social science. We're really excited about sociology. Like being in Soc 5 is like a win for us. That's like a class that a lot of people are going to take, and we're going to expose a lot more. The AC classes that are here. We've done a bunch of work with AC classes. The AC, just if you don't know, is American cultures. All undergrads have to take a class in something that's called American cultures. That's going to expose them to other cultures besides their own as part of like the American, the American story. And we have had a big success working with these American cultures classes. And it's a really interesting experience because you get to teach these little elements of data science to some students that didn't sign up to take a data science class. They signed up to do, some sociology class or, some psychology class, and they're talking about implicit bias and stereotyping and gentrification and other issues. But those professors find a way to transform their homework and giving them some elements of statistics and background to this discussion about implicit bias. So we're really excited that we're adding 2 more AC classes this semester, and we really hope those are a success. We also generally here, we're interested in open science and community and reproducibility. We're interested in sort of promoting these tools on campus. A lot of different graduate programs are looking to sort of adopt aspects of reproducibility, and where's the space for this open science and reproducibility to fit into teaching and not just into research programs. So there's a community that we're looking to create. Some of the terms that we use really quickly. So what we call generally, that we've called this meeting for, we call modules, data science modules. And this is when you have an existing class and you want to stick some data science Jupyter notebooks into it. It's not the purpose of the class, but it's like a way to do some applied homeworks or, a lab exploration. Sometimes it's like the final paper will be doing this. Connector classes are another thing that we talk about and we work on a bunch. I haven't quite mentioned them, but this is the idea of you're in the big Data 8 class, so you're in the 1,500 person class, but then you can take a connector class that's an applied 2-unit class that might tell you about a domain. Last semester there was an EPS 88 that was an interesting applied one. It gave people examples of Earth and planetary science in Jupyter notebooks. I taught one on economic development before. That's how I got in this game. I had worked in Africa. I had this really cool project in a data set. So I was telling this narrative story about what it's like to do international development, but using this tool set that the kids are learning in this big class, that they're learning these fundamentals, and then I was giving them an illustration from my time working in Africa. So there's a whole bunch of connector classes on different themes. They're worth looking through. They could be of interest to you. I think I was just telling you about one that had some mapping in Oakland. So there's a place that a lot of different stuff is demonstrated. As far as browsing what's been done in Jupyter notebooks, they're a great place, great resource to look through. And finally, we have something we call data-enabled course, and that's when somebody's going to like redo their course to have it based on using Jupyter throughout the course. These are a little bit more rare. We've had like 1 or 2 econ classes. There was one last semester, an energy resources group, where they did some like machine learning. So they like baked it into the whole semester. Here's just a list of connectors. So this was a year ago. Geography, sports analytics, that was the really popular one. There's one in the business school. There's one in legal studies. So all different areas are teaching these classes and giving people like, oh, maybe I'll go in that area. So while you're a freshman, you're taking Data 8, you can be exposed to data science in another domain. Modules, just like we have these all over the place. We'll go and look and browse these later, but we've done rhetoric, gender and women's studies, ethnic studies, linguistics, cuneiform, psychology, sociology, economics, legal studies. So our goal is like interact with humanities and social science and not have data science be something that's like stuck in the STEM corner of campus, right? Like our goal is like get out there, find people that want to work with us. So there's been 40 courses so far. We're probably adding somewhere between 5 and 10. So this is going up every semester. I think this number is from a year ago. We also use the term modules as for the name of the team of students that we use to make your materials. So we also say like the modules team built the notebooks for you guys. That's just sort of an internal term that we use. We call modules like the people building the Jupyter notebooks for classes. Okay, so here's the main part of what I want to present to you is like what I call a pedagogy platform. It's a suite of tools that go together. But we'll start, and they built this suite of tools for the big Data 8 class. Really important is this idea of like inclusion and accessibility, right? Everyone should be able to do it. The idea of Data 8 is you can come in with the math you took in high school. It's an intro level class. You don't need calculus. You don't need linear algebra. You don't need a fancy computer with fancy things installed on it, right? So their starting point is like, let's make sure everyone can do this. Let's not make them buy a software or have a special computer. They originally had Chromebook carts, and you could go to the library and check out a Chromebook for the semester. So inclusion is sort of like a starting point here. It's also built to be scalable. So crazy chart of how many people took this class, right? It was like 100, then 200, then 500, then 1,000, and now we're at 1,500. So they had to build this thing with these open source tools so that it could sort of exponentially grow. So it's deployed regularly in this 1,200 person class, but can also work for our connectors and our modules. So what we'll all be using is like this infrastructure that was built for the Data 8 class, but it's so easy to just scale on additional users and scale on additional use that like collectively all of the students that are covered by the people sitting here are like this much compared to the total quantity of people that are in Data 8 and Data 100. Other important elements. It's an open textbook. It's a free textbook. It's like on GitHub, and you can read it and you can adapt it for your class. It's all based on open source software. All the tools are out there and free for everyone. Sort of the approach to building the curriculum, like you can go and see how they built the class. Everything's sort of publicly available the way they built it. It's a little hard to explain, but a lot of times the reason they built things that way is because of the scalability thing. There's a bunch of like going from 100 to 1,000 that had to do with how they built it. And like you can you can change instructors and respawn it the next time. So you build the class into this big thing each time, but because they use open source tools, it's really robust to that happening each time. As a side note, there's now a MOOC called Data 8X, which could be getting like 10,000 users, right? And because this infrastructure is built, it's just it's in terms of like turning that on and provisioning a server that's going to be able to take 10,000 people. So importantly, these tools that they've used for Data 8, we're going to use for our class. They can be used for any type of class. They can be adapted for different types of uses. Okay, so what are the elements?
Quick question here. I know you don't need a full explanation, but based on what you just said, it sounds like proprietary software is built to be non-scalable so that it can be commodified. Is that accurate?
I would say it's not, I mean, Microsoft wants to make sure everyone uses Microsoft, so there is like economies to scale in any software project, but commercial things are meant to be chunked up and have individual user licenses and, give it away for students so that then they have to pay for it once they go into the professional world. But yeah, certainly the commodification of software needs to implicitly put limits on things, right?
Yeah, I was just wondering how it affected scalability, but maybe it's a company's question.
Yeah, well, so different companies take different approaches, and licensing changes over time. Like sometimes it's like you have so many MATLAB licenses. I know though for Stata, like the university has like 100 Stata licenses, and so you can go steal a copy, or you can go to the lab in the econ department and use one while no one else is using it. But if it's the day before the final project is due, you might have to wait till somebody gets off till your license works.
Also, it's a license issue and not actual built into the limitations within the software itself.
Right.
Okay.
I mean, that's a different thing, so they could get infinite Stata licenses and just scale it up to everyone. So Econ 140, that's like a 500-person class teaching econometrics. So how does everybody get a copy of Stata? Right. If we do it with R and we do it with this Jupyterhub, like it's just built in a way that like everyone would get provisioned. MATLAB, similarly, there's a certain number of licenses. So the other thing is you can just get students to buy a license, right? You're taking this engineering class, buy this MATLAB license for this year. It's $50 or $100 for the student license, and that's just like something that people do. But then like that's their skill, and then when they leave to be an engineer, they'll have to get the professional license, So there's just there's a way that things are segmented. Yay, we got a professor here! Yeah?
I have a question.
Yeah.
What does open source mean?
Open source.
Yeah, does that mean like everyone can change the machinery of
The code of the software.
Yeah, that I wrote for my class, or it's free only?
It means, it's complicated because it means multiple things, but for software, it means like it's all published for you to see, and you can, make a copy, and you could change a copy, and you could use a different copy, right? It's not like you can't see what's the base code that's compiling something. So open source software, I guess importantly for me, is more like there's a community of people contributing. Like what's powerful about open source projects is like lots of people from around the world are building the next thing, right? And so like R packages, like there's always another R package, and there's always like an improvement on the R package. And if you think of a problem, somebody's working on that problem and trying to build a package for you. So that's what I think open source means, is like disaggregated people around the world are working on something. Instead of you're like, oh, when will that company release the thing that do what I want it to do, that patches the thing that didn't work last time, right? You're not like waiting for that release. You're like, you're collectively, working on something. We should definitely talk about this. Jupyter is an open project. It's sort of like inherent to what Jupyter is. R is an open project. So we are going to mostly be working in Python. There's one class here that's using R. We can talk about R. I'll talk a little bit about R later. But basically, we're going to teach students little bits of Python for data manipulation, for data visualization, for basic statistics. So we're teaching students a little bit of Python to do a little bit of statistics, you could think, generally. There's a package. So Python is just a general language. And then there's packages within Python, which are sets of commands that do different things. UC Berkeley has a teaching package called DataScience. And we can get into that a little bit. It's simplified so that it's easier for people to learn. So it's like a simple package for students to learn. that was made for the Data 8 class. And a lot of the modules, we do it in this data science package because it's the most simple for somebody who's never seen Python or done any statistics before. Jupyter's the thing we're talking about a lot. It is a way to make notebooks that include text and code together. It's a way to manage the Python code so that you can distribute it and hand it out to people. It's a way to annotate it and illustrate it, so it's not just like a raw code file, it's something that looks like a lesson. It looks an awful lot like something that you would hand out to people or email as a PDF. Importantly, Markdown is a way that you can format things. It's like a very simple way to format things. Like instead of using Microsoft Word, you're using Markdown, like the simple formatting language. LaTeX, if you do any science, it's the way to represent equations, like Greek formulas. So those can all be embedded really easily. You can put images in there. You can actually do a million things. You can put YouTubes in there, everything else. But you can sort of make this living document that has all these different elements and little bits of Python code. The next thing is called DataHub, and DataHub is a server that UC Berkeley runs that anyone at UC Berkeley with a Berkeley email can get to and authenticate themselves on and run files on. It's not actually physically anywhere at UC Berkeley. It's in the cloud hosted by Google, but there's some system administrators at UC Berkeley that run the UC Berkeley one. It's called datahub.berkeley.edu. That's where we'll be working later on. A little bit important to differentiate from the next tool, which is called Github. Github is both, I'm going to say it's two things. For one, it's a site where people host software projects. Like most people in the world that are working on software projects, especially open source ones, are collaborating through using GitHub. It's a little bit subtle because GitHub is also a set of tools that are a way that you can upload files and track your changes. And suppose multiple people are collaborating on a file. You can upload a file. I'll upload a file. It can tell what the difference between those two files is. It can timestamp who did it first and who did it second. Suppose you worked on Monday and then you worked on Tuesday. It would keep track of those, and it would have a way to be like, I accept the change, I reject the change, or I will merge them back in. And complicatedly, it's a way to manage that process. So if you think of people who are working on really complicated software projects, they need all this to keep track of different bits of code and like, how did it run before it broke? Oh, I remember it used to run this way. I'll go back to that version. We're going to use it because the people that we work with are software coding kind of people, and so that's like their workflow. And we're going to just teach you the little tiny bit that you need to know for our workflow. It's a whole world that you could go into and take a whole class about. But we're hoping that we can like expose you to GitHub and you can sort of touch it, know what you need to do. Finally, this is a really funny last one that's not even a big thing, but it is kind of the magic that makes it all work. It's called the Interact link. And that's sort of what we'll hope that you can do today. An Interact link is a way that you can send a link to your students or put a link up on your B courses, and they can pull an assignment from where it's based on GitHub over to DataHub and work on it, work on their own copy. When they use an Interact link, everyone gets their own individual copy of the work. And we're going to show you how to do that today. The one other big thing that I want to say about our pedagogy platform is our student teams. We have really awesome students who do this stuff, many of them for free, for just the experience. A lot of people that have like written the notebooks for your class just did it because they're just awesome. And so appreciating them. We use the term curriculum developers, so students on the teams that built your notebooks we're called curriculum developers. In the connectors, we have students that just like serve as helping their fellow students learn in the connector classes. The Data 8 staff, I don't know, what do you think? It's like hundreds? It's like maybe 100, 150 undergrads just work to run that Data 8 class. And they just get the experience of like teaching, and there's like tutors, there's UGSIs, there's people that run lab sections, there's all these different ways that they learn by helping each other. And I think it's a really awesome part of the pedagogy that there's like this culture of students teaching other students. Okay, so really quickly, Python. Python is one of the most common languages in the world. You can do it to run a server. You can do it to program a web page. You could do any software project you want to do it. It's not just the data science language, right? It's super broadly used. What I would like to pitch to you that I think is great about Python is it's sort of readable. They sort of use words. Like if you had seen C or JavaScript, there's a lot of colons and brackets going on. Python is relatively composed of words, and the package that we'll use for your classes is relatively more like, pivot the table, select where, drop the row, lots of things that like sound like what you're doing and look kind of like what you're doing. You have to learn syntax, you have to learn where the brackets and the apostrophes go, but relatively we're trying to keep things where people are learning programming using words. The reason I think it's a great selection, and we can talk about this later when I talk about R, is the people in Data 8 want to teach computing and statistics at the same time. And that's what I think Python's good for. Is like you're learning some elements of like the logic of computing, and you're learning these elements of like what is statistics. So Python's sort of serving both of those. The data science Python package is this smaller set. So we pull our package in at the beginning. So data science package, you'll see this at the top of your notebook that they're pulling it in. Importantly, when you ask the internet for answers, which is how anybody does any coding at all, there's not as much about how to do things using data science as using other packages, because we are in a little bubble here. So I'm going to remind you that there is a special documentation page for this data science package that's hosted at the Data 8 website, and I'll send you a link to that. It's just sometimes you don't like get there right away just by Googling things. It doesn't show up in Google as much. Naming something data science was not like super foresight of Google ability, right? It's like there's too many things called data science. But importantly, as I said, the reason we use it, there's less commands to learn. It's easier to read. It's simpler. You can do things in like one simple line that in another one that you would have to maybe do 2 or 3 lines. So we still believe in it. Once you get into Python, there are a lot of more cool packages. So this is all about like learning which package is appropriate for your field or for your project. NumPy is like doing everything to do with numerical manipulation, so we almost always use NumPy. SciPy is a big one for all sorts of science and scientific manipulation. Pandas is the one that's the most like R. It's panel data sets. So it's the most like tables and, like what's the R world? The tidy world of R. It's like people in Python trying to follow along the tidy world of R. If you were to go be a data scientist long term, like if you go to Data 100, you learn Pandas. If you're in Data 8, you start with like the simpler package. Matplotlib is the big thing for graphing, so we're actually almost all going to touch something about Matplotlib, like some little data visualization, some dots, some lines. Folium is the one for mapping. Stats models is another way to do it, like all kinds of regressions. And then there's scikit-learn and TensorFlow. That's the really sexy thing right now where it's like machine learning. So those are just a command line away. Once you're in a Jupyter notebook and you got your data set in there, you could be applying machine learning to it in a few more lines of code. So the Jupyter notebook, I was going to say it's if people know that it's for multiple languages. So there's a language called Julia, there's a language called Python, and there's a language called R. So that's what the Jupyter name comes from. That it can read multiple languages. Jupyter, Python, or R. It is a big project. It's importantly, how do I say this diplomatically? There are many of the core people here at UC Berkeley, including one of the founders, and he's super awesome. He's a stats professor, and he's totally worth meeting, and he's amazing. And over at BIDS, there are many of the people working on the Jupyter project itself. But it's a global project. We could be living anywhere. We could be, doing the same thing anywhere we are in the world because it's like universally available. We're just close to the heart here. It can actually use almost any possible, like you can actually do MATLAB and Stata, and you can do almost a whole bunch of other things in it. So it's a way that like you can call the computer's code compiler back and forth iteratively as you go through it. It's also a really good way to share things, so it packages things up nicely. So one of the questions is, how do I share just the little bit of code that does my project with somebody on the other side of the world? Right? So I'm going to package up my description of what I'm doing with my little bit of code, and I'm going to see if somebody on the other side of the world wants to like look at this and review it and see how I'm doing. Right? So that's part of the vision. It's meant so that while you're in it, you can interact with it. So I sent my code to the other side of the world, and I was like, oh, look, I think I found a black hole in sector 43. Can you check my code? And the person on the other side of the world, when they get the package, they could change a little bit, and they could interact with it once they got it, right? And it's got really powerful tools for using big data. So none of us in this room are necessarily using big data, but we were talking about yesterday, we were working with some business school people, where, and related to this class, I think some of the homeworks that we've adapted in this class were previously done in Excel. So Excel's like, maybe I got 50 rows, maybe I got 100 rows, maybe I got 200 rows, right? But what happens with these is like, then you can go to 1,000 rows, then you can go to 10,000 rows, then you can go to 1,000,000 rows. Like in a Jupyter notebook, it would be nothing to make the data read 1,000,000 rows versus, whereas in an Excel notebook, like to go from 100 rows to 1,000,000 rows, it's going to sort of break your workflow. And this is sort of a part of this moment that we're living in. We're like, we need to switch to these tools because there's more data coming over the bow every moment. Here's what it looks like to be in a Jupyter notebook, and so in a little bit we'll jump in and do it. Basically, you're looking at a bunch of rectangles, and this is a rectangle of code. You can up here press run and just run that chunk of code, or we do control enter. And so we just run those little chunks of code. And here is a chunk of markdown. So up here it says markdown or code. So this is a chunk where we're writing, a descriptive bit of text. And so pedagogically, there's a whole thing of like how to make these notebooks up that sort of artfully mix the code with the explanation. Like in reproducibility, it's like, how did I get here? Why did I do it? What was the assumption? Where did the data come from? In teaching, it's like, what are we going to do? What's the next step? What's the next thing you need to learn? Here's the question that prompts the next thing. Here's the part where you're going to fill in the answer. So sort of like, in the pedagogical notebook is more like how to prompt the student to get through to the next bit of code. Really great article that I recommend to everybody called "The Scientific Paper is Obsolete." I'll send you the link at the end, but it's talking about, is Jupyter Notebook sort of the future of scientific publishing? Like, should everybody be required to, like anybody using data, should they be required to do this in the future? There's a whole bunch of journal articles that have been retracted because somebody cooked the books on their data. Or somebody, dropped something or missed something on the data. And maybe this is the future. It's really good because it also interviews Fernando Perez, who, as I'm saying, is the stats professor on campus, who's a charismatic leader of ours. So it's a nice magazine article version that might be interesting. Really quickly, a pitch for Reproducible Science. All graduate programs on campus should be thinking about reproducibility. What are the elements about reproducibility? Literate computing, so documents that everything's marked up and everything's sort of explained what you're doing in your computing documents. Version control is part of reproducibility, so when did you do it? What did you do it? Who contributed which elements to it? So if we're using GitHub, we have all of that. automation, so what little bits and programs are calling other sub-routines. Where is our data? Where did it come from? What steps has it been to get there? Is there a version of the data that's put up and publicly available, or is it just only on the hard drive in the lab group? And sort of a computational environment that can work across. So it doesn't just work on my laptop with my version of R and my little thing installed, but it works on every possible computer that would run it. Right? So these basic elements are things that we're learning, that our notebook session here will be teaching you. So this is reproducible science is sort of unrelated to our teaching, but it's using these same practices. If you're interested in talking about reproducibility, we have somebody here who's an expert in it. So then there's this server at UC Berkeley, and this is a little confusing. So there's Jupyter, the way that you can make a notebook, and then there's something called a Jupyterhub that's built at UC Berkeley to serve Jupyter notebooks to researchers and students, mostly students at UC Berkeley. datahub.berkeley.edu. It has its own file server. You all get your own copies of the Jupyter notebooks, and they live here on this file server that you log into. So we will get there. We will work on it. We will look at this in a little bit. Separately, there's something called Github, which we will also go to. So the place where we work, where we put all our work up to, is this place, DS Modules. github.com/DS modules. And we'll all go there in a little bit. Each class will have different, really quickly, there's a term here called repositories, or what the folders are called, but everyone calls them repos. And I will slip into just calling them repos henceforth after this moment. So there's a GitHub repo for your class that we will find. And you can click around. There may have been an issue. There may have been a pull request. There'll be different contributors. The commits are every time somebody changes the code, it's called a commit. So there's a whole bunch of terminology about GitHub that you don't have to actually learn, but you can observe it and take it in. And if you're interested, make yourself a GitHub account, and you can become. You don't need to make a GitHub account, but you can make a GitHub account. And we'll show you how to get in there and work around. Interestingly, it can host many things because as a place to host free software, it hosts all of the things that build Data 8. So it hosts the Data 8 website. It hosts the Data 8 textbook. It hosts a bunch of elements, like everything that is the Data Hub that we're talking about, like the server at UC Berkeley that can serve thousands of students every semester, that's all on GitHub. So like all these different elements are like freely hosted there. Anybody can go inspect those elements. So it's a whole workflow that encompasses many different aspects, not just the Jupyter notebooks at all. It can be used for so many different things. Right now, we're like, that's where our Jupyter notebooks and the data sets that go with the Jupyter notebooks are. All right, and the last two things, some of the last two things are these interact links. So this is a way that we take where we think the Jupyter notebook is, and we can paste it in here. We'll tell it we want to go to DataHub, and it will make this complicated link that we can then distribute to students. There's two of them. That's the old one. This is the new one. So here, we want it to open at datahub.berkeley.edu. If we were at, in Vancouver, Canada, we would have a different Jupyterhub to send them to for those students. But we could be teaching the class at Berkeley one semester, and next semester we could go teach it in Canada. We could refer to the same GitHub repo, but open it in Canada next time. Here, if we want to open our studio, instead of Jupyter, we would have our studio tag. This is sort of subtle, but Jupyter's moving to Jupyter Lab, so we can also open things in Jupyter Lab. We can also open specific notebooks instead of just our whole class repo. But for now, what we're going to say is let's just open the class repo and not the notebooks directly. So we will all practice this in a second. So just thinking through a workflow, right? Did you have a question?
I think I'm just a little confused. What is the relationship between, like, can you give me a metaphor for GitHub and Jupyter and how that, like a Google Docs metaphor or something? Like, because one of them, I'm picturing Jupyter as like the doc and GitHub as like the drive.
Yeah, I will get to that. It's super, people are often confused about this. I'll get to it, but I'll do a quick one right now. GitHub is like a place, for our workflow in here, GitHub is a place where somebody has stored something for us to go get. There's a document that has an IPYNB ending. That's like a Jupyter notebook, has like a certain kind of file. Jupyter, it used to be called IPython notebook, IPYNB. So we're going to go to GitHub, get our copy of our Jupyter notebook, and pull it into DataHub. And then we're going to go to DataHub and open it and work on it. And then when we're done, we're going to save it to PDF and we're going to send it to the TA for grading. But I'll walk through that in a second. So thinking about building stuff, right? So we can go in DataHub and we could build a new notebook. And I'll show you where we could do that in a second. We could open DataHub and we could say, I want to make a new notebook. And we could just start getting some code from the internet and typing up, like, here is my project on, earth science. Here's a way to measure earthquakes. And then I could take the code that I had and paste it in there. And I would be making a new notebook. GitHub, this other place, I could go and put my code there. Say I'd made a Jupyter notebook, I could then put that Jupyter notebook on GitHub. I could make a repo. Here's my new class repo. So I'd be like, here's the place where I'm going to put the notebook for the students to find it. Then I could make this interact link. Hey, students, go to GitHub, get a copy. And then I would put the link, send the link out to the class. I could put it on B courses. I could email it to the students. We could be working together, and I might not be done yet, and I could send you a link. Hey, check out this latest copy. Open it up. See what you think of this version. How does the map look today? Is that going to work for you? This is just our workflow. So we work on building the notebooks. First, we meet with the professor. The professor brings a syllabus. Often they bring a problem set that is usually coming from Excel or coming from MATLAB. And we're like, okay, that looks really easy. We could take what you've done in Excel or MATLAB and change that into a Jupyter notebook. And some students will work on that. They'll work with the professor, get feedback from the professor, get feedback from us. Then usually, and I don't know what the case of each individual class is here, but we can get time for the students to come in the class. And sometimes, when we deploy it in your class, our students will come to your class and help that one day that you're deploying the notebook. Or a lot of times they will go to the lecture the first day and the professor yields a little bit of lecture time, and they'll be like, all right, everybody, this is DataHub. We're all going to use DataHub today. And they'll have a simple first notebook that might not be the homework notebook. That's here's the first notebook. Let's all go in there. And we'll try that right now. Then the professor sends out the interact link and then collects them later as a PDF. Here's my graphic of what I just made this right when we're coming over here. So there's some flow here, right? So this is a B courses flow. Does B courses work for you? So every class has a B course. Students see it. That's where assignments are. You could be like, assignment 1, due on Friday at 5 p.m. Here's the link, right? Students would click a link from a B course assignment. The link would say, hey, GitHub, pull that assignment into the UC Berkeley Jupyterhub. There's no logo for the UC Berkeley DataHub. There's just the general logo for Jupyterhub. Those two things are interchangeable, DataHub and Jupyterhub. So anyway, pull a link. Every student that clicks the link will get their own copy. Exactly the same copy that's going to do exactly the same thing.
Quick question, when they do that first jump, do they have to have their own GitHub account?
No one needs a GitHub account.
Perfect.
Yeah, so this is something that's interesting to me. 1,500 kids are in Data 8. They don't know anything about GitHub. They never see GitHub, right? No one ever tells them there's a GitHub. They've never heard of it. The textbook's there. All their homeworks are there. The website of the course is there, but they never see it. Right? It's all invisible to them. I think it's a little bit magical. Oh my God, there's my homework. All right, so then you're in there. You do your homework. You do homework 1. You run through it. You read a little bit. You run some code. What I did in my class was I didn't actually require them to do very much coding, but I had cells that said, question 1, fill in here. What happened in the graph above? I was just going for intuition, like, oh, it looks like that, the drinking water wasn't as clean as we thought it was, or whatever, just write in the text. Or it could be a coding problem. Figure out how to do the correlation. What correlation did you find? Something like that. So it could be coding, or it could be typing. Then our workflow is going to be they can save that as a PDF to turn it in. They could turn it in right back to B courses under assignment 1 by Friday at 5 p.m., upload a PDF. Gradescope is really popular for PDFs, so you can also set up like assignment 1 on Gradescope.
To be clear, you're running the notebook in a browser.
In a browser.
Chrome or Firefox.
Yep, absolutely. This is all for people to run notebooks in browsers on the cloud. So you need internet.
Once a student gets their homework assignment, is there an easy way for them to reset? Say they just were choking off basic and want to reset. Could they get a new homework assignment, or as soon as they get it, is it assignment?
If they click the link again, it makes another copy, but doesn't overwrite what they did.
So close to it. So the logic is that by default, it's going to prefer, it's not going to change anything that you've added or you made. So the student's not going to click the link again and accidentally erase code that they've written or written responses. If there is some kind of catastrophic problem that they've gotten themselves into a mess and just want to start over fresh, they can rename that folder as messy homework, click the link again, and it'll pull a fresh copy.
Or delete the folder on their local.
That's the other option.
On their local, on their B courses.
Yes.
I mean, DataHub.
So
Sorry.
rename the folder or delete it, they can get a fresh copy.
Then it would do a fresh copy. But if you do it directly, if you click over and over and over, it won't write over your file.
You would just have 5 different files.
Yep.
No, you just have one. Sometimes it does a thing where it adds a hash to it, but generally the main one won't change.
So in order to get a new one, you would have to either rename it or...
Yeah. Like a blank copy. Yeah. We can look at that a little bit. So one thing is so where the coding sections are, there's a section of code and there's a section of output. When you ran that section, it made the graph, or it ran an output, or it threw an error. And so you can also do an important part where you clear all of those. Sometimes you just want to go back to run it fresh without all of the outputs that you've already generated. So I can show you where it's clear all outputs. And that can be really, really helpful. Yeah.
Regarding students that have different computers, all the interfaces all look the same.
Yep, browser window.
They have iPads.
Yep.
It's all the same. Great.
I mean, generally you need a browser. So, I mean, I can make it come up on my phone.
Okay.
Right.
Just in case a student forgets their laptop.
No, it's
or
super
they
important.
Or whatever, so I can say, okay, pull up your phone, we can.
Yep.
Okay.
iPad, tablet. It definitely works on iPads and tablets. The iPad or tablet, if as far as just running it's no problem. But if you want to do a bunch of typing, it's just harder on a tablet. But lots of people have keyboards for their tablets. So. There are Chromebooks in the library that you can check out, and I think there are usually some available. Sometimes a student will actually lose their computer in the middle of the semester or get stolen or something, and this is amazing because all the work's there, and they can go and be in the middle of lab 2 and it'll all still be there, and they can check out the Chromebook and finish the semester, which is awesome. Okay, I'm going to keep going. So this platform is widely used. It's used for all sorts of different classes. It's used for awesome modules that we would love to show off to you. It's used for much bigger classes, much bigger, more complicated classes. So it's sort of it's really easy to be adapted to different uses. Somebody just wrote me a week before the semester and wanted to have some Jupyter notebooks in his class. Can I use it? There it is. It's there for you. Okay. I'm also going to make you go here. This is our sort of documentation write-up page. So I'm going to send you all these links at the end, and we'll have some computing time. But we have a guide that has everything written up. It's called the curriculum guide. It has a bunch of stuff of like, what's it like to be the GSI deploying this in a class? It was originally written for connectors, but everything basically works for you guys as well. So most everything that I'm covering today and a bunch of your like most important questions are going to be in this like online book that has references to stuff. Just pedagogically thinking about using notebooks a little bit, I like to just step back a little bit and like, we're using this tool to teach. So one thing to think about is like, how much is the notebook filled out? How much is it pre-filled out for them? Right? Suppose you want somebody to do this little bit of data science. You could just like read in the file for them and then get them to do it. Or you could read in the file and take the mean and the median of the first variable and ask them to do that for the second variable. Or you could look at the correlation between these two variables and what variables would they want to look at. So there's some continuum of how much you do pre-fill for the students and how much do you challenge the students to learn. A lot of the way we teach is like, here's the command for one thing, now use this command for the next thing. Here's us doing it with one variable, you do it with the other variable. But potentially you get to the final project or you get to something more ambitious and you give students basically like a blank notebook. Like, here's the whole one that you did for homework. Now you could do another one for your exploration of another project. So just thinking out loud, you know, most of your notebooks are built, but this is an interesting thing to think about the pedagogy. Like what, and you know, for like an AC class with people that aren't data scientists at all, maybe you want it mostly filled in. If you're in an engineering class, maybe you want it like, you want to challenge the students to learn a lot more coding. And there's a lot of this in the Data 8 pedagogy, like figuring out what's the right amount. You know, how long should an assignment take? How many people should be able to, you know, should 100% be able to complete it, or should a couple people need to go to office hours? You know, like what's the right amount of hand-holding or independence or autonomy? What's the right number of hours assignments should be taking students generally? So some of this we touched on, Python versus R. A lot of the people in the university are learning R, are using R for research. Less people in this, you know, a lot of people are using Python, but less so for statistics. So the reason we promote R is it's got this great linkage. The reason we're promoting Python is a great linkage to Data 8. It's more familiar. Python also has better auto grading. So in the people at the 1,500 person class, they really like auto grading. Python has more developers behind it, so because we have students coming out of Data 8 to work on, we can build your notebooks. We don't have students coming out with our experience, so that we have less people to build our notebooks. We want to build that capacity. Probably there's more people in econ, like econ professors, probably there's more of them using R than Python for stats, for sure. So they're both industry standard for data science. Python generally has other things that it does besides data science. Importantly, we have one class this semester that's going to use RStudio. So this is seeing the browser window. You can serve RStudio on DataHub the way that you can do it for the Python as well. That's just sort of an aside for the people that are into R or teaching in R that we're hopeful about. Oh, look, it's the Econ 172 notebook. So this is back to this question of like open source, open science. It's free for students. They're learning programming skills that they can adapt to other things. I believe like students learning Python, it's more adaptable to more jobs than learning Stata or MATLAB, like in terms of like total number of different things you could be doing. So different directions you could be taking it. Open source, I think, for us means it's really easy to deploy it in a lot of places and promote it to other universities. We're also promoting this like methodology and Data 8 to other universities. And if we were tied to commercial practice, a commercial product, we'd be like, all right, well, try Data 8, but you also have to buy the license for this thing, you know. So this is like, try it with these free tools. I'll just really quick on other things, and we can move on to the practice part. These aren't part of the orthodoxy, but I'm just need to tell you about them while we're here. First of all is you can go to Anaconda and you can install Jupyter and Python on your computer locally. Like, you don't need to do this all in the cloud. If you were a computer science or a data science student, or if you were going to be doing R, you should generally be installing those things on your own computer. So you go to Anaconda, it's free, it installs it all. If you're going to do a lot of developing, it's a lot easier to do it locally on your computer. You can get all these things to run there. One thing that's important, the data science package that UC Berkeley uses is not included in the Anaconda installation, so you have to remember to install this data science package if you want to read the notebooks that we're working on. Second, Google has a really interesting product called Colab. colab.research.google.com. It's free. It reads Jupyter notebooks. It works with Google Drive. Once you have it installed, you can Gmail a notebook to somebody and a button will be there that can open a Jupyter notebook from your Gmail directly into this thing. And it's like working really well with your Drive folder. The people that we work with at Jupyter don't love this approach because it's not the same open source project as Jupyter. So Google has sort of like taken their own little pathway. It's interesting because it's a way for us to share notebooks as well. And Google's giving it a bunch of server space away for free. Like, you can go and use free compute time doing really complicated things at Google. So this is the giant corporation giving away some services for free. The Jupyter people think that's worrisome that they're going to create a captive community where people have to use Google services. So a little bit controversial, but I think it's relevant to know that it's there. We use Google for everything else, so we use their Drive and their Gmail and everything else. So the fact that they have free Jupyter notebooks is also interesting. Most people don't know about this thing. It's a weird thing that's a sort of like hidden there. DLab, as I already talked about, if you want to learn any more in Excel, Excel like yourself, go to DLab. Here's the calendar for this month. Look, this week R is almost over, but next week, in 4 sessions, you can learn Python. So anyways, DLab's awesome. We have many different ways that we're related to it. There's lots of great trainings and lots of great people. In your graduate student travels, if you ever have a complicated project or a dissertation, they also are like consultants where you can go to them and like get actual like, help me with my project, I need to do this. And they're there to work with graduate students and to train you. One other one that's really interesting part, and it's also coming out of UC Berkeley, is another way to serve Jupyter notebooks called Binder that's free to everyone in the world. And so it's a Jupyterhub for everyone in the world for free. So if you wanted to distribute something, how do I say this? If you had an awesome Jupyter notebook that you wanted to tell the world that you had worked on, you could offer the Binder link, and anyone in the world could click it and would open a Jupyter notebook for free. It's on donated resources. It's a really funny thing because it's really slow. So it's free, but you click the link and it's like, but eventually it pops up and it totally works. So this is a vision of like, you know, computation should be evenly shared across the world. So somebody in Africa could be learning geophysics about earthquakes, and they could click this link and they would have the same notebook as somebody, you know, in UC Berkeley. And this is using a bunch of the technologies that we're talking about to, you know, sort of like distribute it openly for free. And it's people at BIDS are working on this. Okay, here we go. We're changing now. Do you guys want to get up and stretch and wave your hands? We're going to do the computer part now. But if you need to stretch, wait, I brought candy. Where's my candy? Chocolates? Anybody need dark chocolate break? Dark chocolate? All right, so now we're going to do a little exercise. So
Yeah. So
Yes.
the point of Binder?
Oh, so in GitHub you could see my code, but you couldn't actually interact.
Oh, okay.
If you go to Binder, then it's like actually running, and you're like, oh, I want to simulate the vision of, I want to generate the graph of something or other. Okay, so go to this little bit.ly at the bottom. And I think it should take you to, I'm going to stop this recording.